Hey, so in this video, I want to give a kind of a low-level introduction to some of the more common aspects of AWS that most services will use when you're spinning up test instances like Kubernetes clusters or EC2 VMs. This is kind of an introductory overview of some of the networking in AWS. I think the outcome of this will be that the support team should be able to quickly spin up their own VPC and use that as the launching point for any other test services that they might need to use to resolve some tickets. So the first thing is how do you actually log into AWS? If you go to the map.octopushq.com, you'll see this link here, Octopus AWS. Actually, if you go ahead and type AWS on your keyboard, you'll see in the top right-hand corner the keys that were pressed. You just hit enter and you get the sign-in window. Log in with your octopus.com account. If this doesn't work, reach out in team operations. I think we'll be able to help you link your account up to AWS. But yeah, we just use our Google accounts here to get into the console. So the first thing to know about AWS is that it's based around the concept of regions, and that's this drop down here. So regions are really just geographical regions where the infrastructure has actually been hosted. We tend to do most of our testing in US East 1. A lot of these regions just aren't used. Things like Singapore and Sydney, I think, actually have production instances, so we don't tend to touch them much. Yeah, so if you just stick to US East 1, you should be good to go. So you can see in US East 1, this is where all the VMs that we use in our end-to-end tests get created and destroyed. There's no instances running now, which is good because it means all the instances were cleaned up after the test ran. But if I clear that filter here, we can see this these E2E tests here have been spun up and terminated as part of the testing of the main Octopus product. So the first thing we really need to do in AWS, and it's kind of the foundation for almost every service that you'll tend to spin up and test with, is a VPC. And so VPC stands for Virtual Private Cloud. Really, it's just an isolated network, kind of a little segment of networking within AWS that other resources are placed into. So there is this launch VPC Wizard here. This does make it actually quite easy to create a VPC. We're going to do it the hard way though, just so we can get an understanding of all the bits that make up all the resources that get put into a VPC that support other resources like VMs. So I've gone to my your VPC here, and I'll click Create VPC. This means we're not using that wizard anymore, so we do have to create all of the individual components manually. So just give it a name, and then you need to define the range of IP addresses that can appear in the subnets that are assigned to the VPC. So we'll get into subnets a little bit, but the default shown as the help text there, 10.0.0/24, is actually pretty good for testing. You're not likely to need anything more than that. Actually, no, we may change that to 16, 10.0.0/16. So what the 16 here means is that each of these dots, or each of these numbers in between the dots, can be a value between 1 and 255. So basically it's 8 bits. And so the 16 here means that 8 bits of 8 bits of numbers really is consumed as part of the network space dedicated to the VPC. And so 16 means that actually 2 of these dots, or 2 of these first octets, are going to be common to all the network addresses in this VPC. You don't really need to have a deep understanding of what this means, but if you want to have a look at what kind of the meaning of this particular string, Just Google for something like a CIDR calculator. A CIDR is classless interdomain routing. And a calculator like this will allow you to paste in a CIDR string like this and see how that breaks down into individual IP addresses. And so what we can see here is that the /16 here means that the first two of these octets are always going to be the same. So they're always going to start with 10.0. And you can see the last IP here is also 10.0. These other ones then are up for grabs. Like these are now available within that range. And as we can see here, we've gone from 0.0 to 255.255. And that gives us a total number of IP addresses of 65,000. So that's 10.0.0.0/16 is a good default to use. So we'll just go with that and click create VPC. This should happen fairly quickly. And there we go. So we have a VPC created. So inside the VPC, we then need to create subnets. And subnets are a subnet represents a network within a particular availability zone, and all resources within a subnet can talk to each other directly. The networking between resources in a subnet is very quick usually. And what I mean by availability zone is that each of the regions here, like North Virginia, for example, I think this one here actually has 5 availability zones. So that's 5 different data centers really in the North Virginia region. They'll be distributed far enough apart that a common kind of accident or weather incident wouldn't affect, that would affect one, wouldn't affect another. That's one of the criteria I think that AWS makes when they try and place a new data center. So the idea is that if you spread your resources across availability zones, you've got a reasonably good amount of protection from any natural disaster. So we'll create a subnet, and I will find this is the one that I created, the VPC that I created just previously. I'll give this a simple name. And this is where we get to select that availability zone. All right, so it's actually got 6 availability zones. It doesn't really matter which one you select here for test resources. So I'll just select the first one, which is 1A. And then we now select the CIDR block, or the range of IP addresses that are particular to this subnet. And so this range has to be more constrained than the range that was assigned to the VPC. And typically what that means is you just add another 8 to this value here. So 16 becomes 24, which is 10.0.0/24. And again, what that means is 24 divided by 8 means the first 3 octets will be common for every device in this subnet. So we go back to our calculator here. What we'll see is that we start at 10.0.0, we finish at 10.0.0, and the only numbers that change are the final octet here, 0 and 255. And so we have a much smaller number of individual IP addresses available in this subnet. And so these CIDR blocks need to be unique per subnet within a VPC. So if we create that subnet, we'll go through and just create a second one quickly. So you can see how they have to be unique. Call this subnet B. We would typically, when you're creating subnets, you're usually creating networks that represent these availability zones. So I selected 1A in the previous one, I'd select 1B here. And the change that I would do to this CIDR block is the addition of that 1. And so what that means is the IP addresses in this particular subnet will all start with 10.0.1, and that will go all the way up to 10.0.1.255. It should actually tell me that they need to be unique if I try and, yeah, so that's an error there, telling me that another subnet already has claimed that range within the VPC. So we just claim the next range there. All right, so at this point we have a VPC. We have subnets in the VPC, so technically we actually have everything we need to start creating other resources like EC2 instances. So let's go ahead and create an EC2 instance here. So I'll just launch an instance. For this demo, I'll just select the Amazon Linux and create a relatively small instance because I won't be doing anything on it. So T2 micro is fine. I do now have to select my network here. And so, where are we? Let's see, test. So that's the VPC that I created just earlier. And you'll notice that I get the option of subnet A or subnet B, and those are sitting in different availability zones there. I will assign this EC2 a public IP address, but as we'll see shortly, that doesn't actually mean that I can get into the instance from outside. There are other settings that we need to configure for that to work. So I'll just do review and launch. Just use this key pair here, Duke Legion, and look in LastPass for the contents of that file. So you'll need that the contents of that file to SSH into this instance. All right, so that's going to take, that should not take too long actually to boot up. What we can see here is that actually there is a public IP address assigned to this instance. So in theory, I can do something like this, which is SSH, and then I'll reference the contents of the key that I got out of LastPass. Ec2 User is just the default user that's configured against Amazon Linux EC2 VMs, or AMIs, I should say. If you went ahead and selected maybe an Ubuntu instance, for example, the username is probably going to be Ubuntu. Fedora would probably be Fedora as well, but for the Amazon Linux ones, it's just EC2 User. And then @ and that public IP address. And so if we just double check the security, we can see port 22 from anyone. So again, this is another CIDR block. The /0 here means match nothing, which really means any IP address falls into this. So this means this this EC2 instance has SSH access from everywhere, from the entire world. But it doesn't work. So I've just hit enter there, and eventually that's just going to time out. There's no public access to this this EC2 at this point, despite the fact that it does say it has a public IP address. And the reason for that is we need to link our VPC to the internet through an internet gateway. And so that's this option here on the left. So I'll just create a new internet gateway here. It creates fairly quickly. And then I do need to attach it to a VPC. And so an internet gateway being attached to a VPC means we have the networking in place to allow connections both in and out of the devices that that sit in this VPC. But we haven't quite got a connection yet, so that's timed out. I'll try it again. As we can see, I still don't actually have public access here. What we need to do is change some of the routing rules in our subnets. Subnet A. That's this one here. So if we have a look at the routing table here, we can see it can really only talk to itself. This subnet doesn't know how to reach out to anything outside of its own subnet. So what we'll do is click on this route table here. I'll just draw this up here. We go to routes. What we want to do is allow traffic that's bound outside of the subnet to go through that internet gateway. And so again, we use that same CIDR block of all zeros. And we're going to direct that to an internet gateway called that. So let's save that route. And that, after a small wait while AWS configures its networking, gives us access. And so I've now logged in remotely to that EC2, and if I try and ping a public internet address, I can see that EC2 actually can reach back out to the internet as well. And so at that point, we now have what's called a public subnet. Public subnet just really means that you have an internet gateway and you have this routing rule here that directs all traffic that's not destined for the current subnet or other subnets in the VPC back out to the internet. So this is a public subnet, and it's got internal and external access. We're not quite done yet. What you really want to do is modify these security rules. This source here is too open. Anyone can just start scraping or kind of probing internet addresses, and if there's any vulnerability in SSH, for example, they might be able to gain access to your box. So what I'll do is actually get rid of that. I've just got a little browser extension here that shows me my public IP, and I'm going to type that in and end it with a 32. And so again, if you recall, every division of 8 in here consumes one of these octets, so 32 means all 4 octets have to match. And so this IP address, or this CIDR block, matches one IP address only, and that's it, and that's me. So at this point now, the networking on the EC2 instance will only grant SSH access from my IP address, and that removes or reduces the attack surface area quite considerably for those instances. So that's definitely recommended that you do that. And that's it. So we now have if we just go back to review, we have a VPC. Which is this one here. The range of available addresses here was 10.0.0.0.16, which meant that all subnets had to start with 10.0, and they'll differ by this third octet here. So I had 2 subnets. Subnet A will have .0.1 through to 255, and subnet B will have 10.0.1.0 to 255. So we then had those 2 subnets here. So this is one of the subnets that we created in that VPC. You can see that CIDR block, the mask here is increased by 8. That just means it consumes the first 3 octets. And we have subnets have routing rules, and by default they'll be able to talk within their own subnet. But this rule here, as long as you have an internet gateway, this directs all external traffic back out to the internet. And the internet gateway was just something we created here and then attached to the VPC. So that's it. I would recommend anyone who's finding themselves debugging or kind of testing a lot of AWS services to run through the process of creating a VPC. You really, almost every service in AWS places something in a VPC or in a subnet. And if you haven't created one for yourself, chances are you're just creating resources in somebody else's VPC. It's not really a big deal because everything should be a test instance in this particular region. But I think best practice is going to be that anyone doing testing should have their own VPC ready to go. Having said all that, this is obviously quite a manual way of doing things. And if you are creating EC2 instances, for example, there is an easier way. So I'm just going to go into our deploy instance here. And in let's scroll down, test infra space, we have a bunch of runbooks that have been pre-configured to do most of this work for you. So I'll click on AWS here. if I go to my runbooks, you can see that we have some runbooks that have been pre-configured with CloudFormation templates that will create the VPC, the subnet, the internet gateway, and the Ec2 instance for you. So this one here will create one of those Amazon Ec2 instances. These two will create Windows 2016, 2019. Just quickly to show you what CloudFormation looks like. That's this service here. Really, it's just a template, JSON or YAML that describes all the resources that need to be created. So it's useful because, as you can see, we had to create about, 4 or 5 individual resources and hook them all together. It makes sense to create them all as one kind of group. So this CloudFormation stack here is the result of me deploying this template here. And if we look at the template itself, you'd be able to see all the components that we just talked about. So an internet gateway, it's attached to a VPC. We have a subnet here. That's the subnet routing information. We actually expose a bunch of these known public Octopus Cloud IP addresses. So this means that you could potentially reach in to a listening tentacle if you wanted from an Octopus Cloud instance. Workstation IP here is a variable that you'd pass in, and again, that variable would just be your own workstation ID. And so the end result of these settings is that Octopus hosted instances and your own workstation can reach into that box. Yeah, so that's it. Just create an instance here. Stack name just has to be unique, so use something like your own name. That workstation IP there is the property, or sorry, your IP address that you put in there. And this will go ahead and run that CloudFormation stack and create an instance for you. And then to clean it up at the end of the day, just remember the name of that stack that you named. You can go in and actually search here if you forgot what it was. So I would type that name here, and that will go through and delete all those resources for you, and it'll clean it all up kind of in one operation. So that's quite handy as well. Okay, so thanks for that. And if you have any questions, feel free to reach out. I think in future episodes or screencasts, we'll look at some of the other services in more detail, particularly CloudFormation. I think that's going to be an important one coming up for a lot of the steps we want to implement, but also services like Lambda and Beanstalk and ECS. Okay, thank you.